everyone. In this video, we're going to determine the inverse of logarithmic function, and this is the second part. Before we go over the example that we have right here, let's have a review on how to convert logarithmic equation to its equivalent exponential form. We remember that logarithmic form can be converted to its equivalent exponential form following this general rule right here. So on this side, we're going to write the logarithmic form. On this side, we're going to have its equivalent exponential form. Before we change this to its equivalent exponential form, we remember that this expression that we have here is read as log of a to the base b equals m. Or the other way to read this is log base b of a equals m. Please remember that this base of this logarithmic equation that we have here is the same base in the exponential form. So I'm going to move that up here so that it becomes the base. I will put an arrow on that one. So the base of the logarithmic function will be the same base in the exponential form. Now this m that we have here is the exponent of the exponential form. So I'm going to put that up there. So this is read as b to the power m. So again, the m becomes the exponent. So I will put an arrow right there. And this argument a will become the value of this whole exponential expression on the left. So I will put an arrow right here. This is where the a is gonna sit. And this equation that we have right here is read as b raised to the power m is equal to a. And this is how we convert a logarithmic form to its equivalent exponential form. Okay, so let's go back to the example that we have right here. We're supposed to determine the inverse of this given function right here. F of x is equal to log of 2x plus 1 to the base 3 plus 4. There are steps that we need to follow in order that we can determine the inverse of a function. The first step is to replace f of x with y. So in this problem right here, this f of x will become a y, and I'll copy the rest of this expression that we have here. Okay, once we've set it up, we are supposed to move on to the second step. The second step is to replace every x with y and every y with x. We're supposed to isolate the logarithmic expression on one side of the equation, convert the logarithmic expression to its equivalent exponential form, and finally solve for y. So in this problem right here, all of the y's, so the y that we have here will become an x, and this x becomes a y. So I'm just going to go ahead and rewrite this. Okay, our target is to isolate this logarithmic expression that we have right here on one side. But then as you can see here, there's a plus 4 on this side. So that we go ahead and subtract 4, because again, our target is to isolate this expression by itself. So minus 4 and minus 4, this will give us okay, so we have isolated this logarithmic expression on the right side of the equation by subtracting 4 to both sides, so that we go ahead and change this or convert this to its equivalent exponential form. So we remember that we can convert a given logarithmic expression using this pattern that we have right here. So then this is the base of our exponential equation, and this will be our exponent of the base, and this will be equal to whatever is that exponential form. So then we go ahead and say that our equation would come out 3, that will be our base. The exponent would be x minus 4, and this part right here, which is the argument of the logarithmic expression, will be equal to this whole thing right here. So this would come out 2y plus 1. So then we are supposed to solve for y by itself, but then we have a 2 and 1 here. So all we need to do is to first subtract both sides by 1, subtract this by 1. So this will give us Okay, now again, we are supposed to solve for y by itself, so we're not done yet. So we can actually show the work on the side right here. So this would come out. Since we want to solve y by itself, we're going to divide both sides by 2 and then divide this by 2 so that we can have y by itself. So this will come out. Okay, we can actually simplify this some more, so we can get the 1/2 here. So this would come out y is equal to 1/2, and then the whole thing would be copied inside the parentheses. Okay, so then we can distribute the 1/2 here to each of the terms inside the parentheses so that we can go ahead and simplify this some more. So I'm just going to show the work up here. So this will come out y is equal to, that's going to be 1/2. And then that's, we distributed it to the 3 to the exponent x minus 4. So 1/2, 3, that's x minus 4. And then we distribute the 1/2 to the -1, so that becomes a negative 1/2. So then after we have isolated the y by itself, we're now ready to move on to the third step. The third step is to replace y of the equation solved in step 2 with f -1 of x. So this would finally come out f -1 of x is actually equal to 1/2. That would be 3 to the exponent x minus 4 minus 1/2. So this is the inverse of this function that we have on this side right here. On the side, you will see the Desmos graph of both the given function and its inverse. In red, you will see the function log of 2x plus 1 to the base 3 plus 4. And the one in blue is its inverse, which is 1/2 parentheses 3 to the power x minus 4 minus 1/2. You can see that both of these graphs are actually symmetric with respect to the line of symmetry y is equal to x. This tells us that both of these graphs are actually inverse of each other. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to replace f of x with y. So this f of x becomes the y. So I'm just going to write that down here. Okay, now we're ready to move on to the second step. The second step is to replace every x with y and every y with x. Again, and we isolate the logarithmic expression to one side of the equation. We convert the logarithmic expression to its equivalent exponential form. And we solve for y. So in this case right here, this y becomes an x and this x becomes a y. So I'm just going to rewrite this. Okay, so our target is to isolate this log of y minus 4 to the base 3 by itself here. So we need to get rid of this -2 and minus 5. So I'm just going to show the work down here so that we can isolate this. Okay, we still have 2 here, so we are going to divide both sides by 2 so that we can isolate this by itself on the right side. Okay, now we are supposed to change this to its equivalent exponential form. So this is how we change the given logarithmic equation that we have here to its equivalent exponential form. So this will be our base, this will be our exponent, so that we can go ahead and rewrite this as okay, so we are supposed to isolate y by itself here, or we solve for y. That's part of the step 2. That's the second step right there. So what are we going to do is we are going to isolate the y. So I'm just going to rewrite this up here. Okay, once we already isolated the y, we can move on to the third step. The third step is to replace the y solved in step 2 with the notation for inverse f negative 1 of x. So then we can go ahead and say, so this is the inverse of this function that we have right here. On the side, you will see the Desmos graph of both the function and its inverse. In red, that is negative 2 log of x minus 4 to the base 3 minus 5. That's the function. In blue, you will see its inverse, which is 3 raised to the power x plus 5 divided by 2 plus 4. You will see that both of these graphs are actually symmetric with respect to y is equal to x, which means that these two graphs are actually inverse of each other. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!